Now, if you are new to this channel, make sure you subscribe, you like and share. Today I'm going to teach us the limit of a functions. Now, there are different ways in which you can solve limit of a functions. One of them is by direct substitution. We can solve limits by direct substitutions. What do I mean by direct substitutions? Let me give you an example. If you're having this kind of examples, they give us lim x squared plus 5x plus 9 all over 2x squared minus 3x plus 15. They say x tends to 0. Now, if you are having this kind of limit, they say x tends to 0. You will discover, why do I say direct substitutions? If you try to factorize this quadratic, you will discover that you won't be able to factorize it. So in this case, when you have a question like this and you try to factorize this and you discover that you cannot factorize it, it is not factorizable, what you do is that you put this value, you substitute it direct into it. That means if I put my 0 here, anywhere I see x, so that will give me 0 squared, that is 0. 5 times 0 is 0, that is 9. This one has turned 0 squared, that is 0. This one has turned to 0, so you have 15. 3 here, 3 here, 5. That is 3 over 5. That is direct substitutions. Let me give you another one. If under direct substitutions, they give you, but mind you, you will discover that the answer given to me does not give me 0 over 0. If it gives me something like 0 over 0, that is another thing entirely. But it must give me a value, real value like this. So, but when we get there, I will explain what I mean by that. Now let's look at number 2. Under direct substitutions, they give us evaluate cos x plus 2 sine x all over 3 cos x, and our x tends to 0. Now, for this kind of limit also, I'm going to use direct substitutions. Now, if I put 0 here, cos 0 plus 2 sine 0 all over 3 cos 0. So, what does that mean? So, that will give me cos 0 is 1. 1 plus sine 0 is 0. And 0 times 2 is 0. That means 1 plus 0 all over. Cos 0 is 1. 1 times 3, that is 3. 1 plus 0, that is 1 all over 3. 1 over 3. So can you see? It gave me the real value. So that means there is no problem. So when we get there, if assuming it give me like 0 over 0 or infinity over infinity, that is not the answer. So when we get there, I will be explaining L'Hopital rule. So, but for now, we are still doing direct substitutions. And do not forget, why do I use direct substitution? Because I cannot factorize it. Now, let's go to the limit by factorization now. Limit by factorization. We have limit by factorization. Examples. They give us something like this in limit. Find limit of x minus 1 all over x squared minus 6x plus 5. They say x tends to 1. x tends to 1. Now in this kind of questions, I would have said we should put this one direct, but we can't put it direct. Now look at this, because this denominator we can factorize it. We can use our quadratic to factorize it. So if you factorize this, don't forget this one is x minus 1 all over. If you factorize this, it's going to give you x minus 1, x minus 5. I believe you can factorize. If you factorize it, it's going to give you this. How do we factorize? When you have x squared minus 6x plus 5. If you do like this, 5 times, that is 5x squared. You look for two numbers that will, when you multiply it will give you this. When you add it, it will give you this. What are the two numbers? The two number is minus 5x minus x. Minus times minus plus 5x times x, 5x squared. Minus 5x minus x give you minus 6x. That means we are going to have x squared. You will not write this one again. You write this and this. Minus 5x minus x plus 5. So if you group this and this together, the minus will be outside though. X is common. X minus 5 minus 1 into, because nothing is common, you put 1 here. X minus 5. So when you put this one together, x minus 1 and x minus 5, you pick one out of the two. So that is what I have here. Can you see this one can be factorized? So if it can be factorized, don't put that. If you substitute it direct, you get wrong answer. So far it can be factorized. Can you see this one can cancel this one out? So I'm having 1 all over x minus 5. Do not forget they say x tends to 1. I can now do direct substitution now. I'll just say 1 all over 1 minus 5. That is 1 all over 1 minus 5. That is minus 4. Our answer is minus 1 all over 4. That is for factorizations when you can factorize it. When you can factorize it. Let's look at another one under by factorization. We are having x squared minus 4 all over x plus 2. They say we should find the lim, and they say x tends to minus 2. Now look at this also by factorization. We can factorize this. This is difference of 2 square. You know, when you have, it can be turned to x squared minus, what is 4? 4 can become 2 square all over x plus 2. X squared minus 2 squared, that is, it give me x minus 2 and x plus 2. Difference of 2 square all over x plus 2. This we cancel this because we can factorize this. So we have this left, x minus 2 left. And they say x tends to minus 2. You now put your minus 2 here. That means minus 2 minus 2. Our answer is minus 4. That is by factorizations. Now let's go to the another limit. Let's go to the another limit. Another limit. So another limit is limit tends to infinity. So I will be explaining this in the next one. Limits tends to infinity, and the limits tends to factorizations, rationalizations, and standard limits, and the rest. I hope this one is clear. So you can try this one by factorizations. They give you something like this by factorizations. Try this for factorizations. Give us lim x squared minus 25 all over x minus 5 when the x tends to 5. This can be factorized. So try this and your answer must be 10.